In this lesson, you will learn what network ports are and what they're used for. You'll also learn about DHCP and how to configure a Linux server as a DHCP client. We'll also cover how to assign static IP addresses to the network interfaces on a Linux system. Next, you'll learn about the if-up and if-down scripts. Finally, you'll learn about a couple of menu-driven tools you could use to easily configure the network settings on various Linux distributions. Just like IP addresses identify hosts on a network, ports identify the services on a host. When a service starts on a system, it binds itself to a port and listens for traffic destined for its port. Ports range from 1 to 65,535. Ports 1 through 1023 are called well-known ports or system ports. These ports are pre-assigned ports and are used for common system services. These ports are also called privileged ports since it requires super user privileges to open these ports. Ports above 1024 can be opened and used by normal users on a system and are called unprivileged ports. I've listed a few common ports on the screen. Port 22 is reserved for SSH, port 25 for SMTP, 80 for HTTP, 143 for IMAP, 389 for LDAP, and 443 for HTTPS. When you type in https://www.mybank.com in your web browser, your computer translates www.mybank.com into an IP address. Then, your web browser initiates a request to that IP address on port 443 since you specified the HTTPS protocol. The service, in this case a web server, will receive the traffic on port 443. The etc services file translates human-readable names into port numbers. Here you'll find a list of predefined ports. You can also add to this list. Sometimes when you install third-party software, you may need to add an entry in etc services for the service that software provides. You can also create entries for your own custom-written applications that use ports. DHCP stands for Dynamic Host Configuration Protocol. DHCP is primarily used to assign IP addresses to hosts on a network. When a DHCP client wants to request an IP address, it sends a broadcast message looking for a DHCP server. The DHCP server then responds to the client and provides it with an IP address and other additional information, such as the net mask, the gateway, and the DNS servers to use for name resolution. The DHCP client configures itself with this information and begins to communicate on the network. The IP address assigned to a DHCP client is leased from the DHCP server. The client will be able to use that IP address for the lease expiration time configured by the DHCP server. If the DHCP client wants to continue using the IP address beyond the lease expiration time, it must send a renewal request to the DHCP server. If no renewal is received by the DHCP server, it will place this IP address back into the pool of available addresses. To configure a Red Hat-based system as a DHCP client, edit the network device configuration file located in the etc sysconfig network-scripts directory. The name of this file will be ifcfg-network device name. Depending on the system configuration and the underlying hardware, it might be ifcfg-eth0 or even something like ifcfg-enp5s2. To get a list of network devices on your system, run ifconfig -a or ip -link. Once you've identified the configuration file for the network device, set the boot proto variable to DHCP. To configure an Ubuntu system as a DHCP client, edit the etc network interfaces file. Add the DHCP method to the inet address family statement for the interface. The line will read iface, network device name, inet DHCP. For eth0, this line will be iface, eth0, inet DHCP. You can also assign a static IP address to a Linux system. For Red Hat-based systems, edit the network interface configuration file located in etc sysconfig network-scripts. Be sure to set the boot proto variable to static. Assign the IP address, the net mask, network, broadcast, and gateway as shown on the screen. If you want the network device to be activated at boot time, set onBoot to yes. To assign an interface a static IP address on an Ubuntu system, edit the etc network interfaces file. Use the static keyword following inet on the iface line for the network interface. Next, supply the IP address, net mask, and gateway address. You can use the IP command to manually assign an IP address to a network interface. To add the IP address of 10.11.12.13 to ETH0, run IP space address space add space 10.11.12.13 space dev space ETH0. You can also supply the net mask by following the IP address with a / and then providing the net mask. To bring the interface up, run IP link set ETH0 up. If the ifconfig tool is available, you can use it to assign IP addresses to network interfaces as well. To add the IP address of 10.11.12.13 to ETH0, run ifconfig ETH0 10.11.12.13. To specify the net mask, use the net mask keyword and follow it by the net mask you intend to use. In this example, it's netmask space 255.255.255.0. To bring the interface up, run ifconfig ETH0 up. An easier way to bring network interfaces up and down is by using the ifup and ifdown commands. These commands are actually scripts that are provided by many Linux distributions. They use the information specified in the network configuration files to configure the interfaces. If you make a configuration change, you can test your change by using the ifup and ifdown commands. Instead of manually editing network configuration files, some distributions supply GUI or TUI tools. GUI stands for Graphical User Interface, and TUI stands for Textual User Interface. Red Hat supplies a TUI called NMTUI. You could run NMTUI as root and use the simple menu-driven interface to configure your network devices. Older versions of Red Hat include a very similar utility called system-config-network. You can use YAST, which stands for Yet Another Setup Tool, on SUSE systems. At the time of this recording, there are no official Ubuntu network configuration tools available. In this lesson, you learned about network ports and how super user privileges are required to open ports below 1024. These ports go by two names: privileged ports and well-known ports. Ports above 1024 are unprivileged ports and can be opened by normal users on a Linux system. You also learned that the primary purpose of DHCP is to assign IP addresses to hosts on a network. You learned how to configure Linux servers to use DHCP to obtain their networking information and how to assign static IP addresses as well. You learned that the ifup and ifdown scripts are available on many Linux distributions and that they can be used to easily bring up or down a network interface. Finally, you learned about GUI and TUI tools that you can use to configure the networking settings on a Linux server.